Okay, section 10.3, dot product. The dot product itself is a very easy thing to calculate. In some ways it's deceptively easy because you think maybe you understand everything about dot products just because you know if you've got a vector u dot product v, okay, then all that's is equal to is you just take the different three-dimensional components and you go u1 v1 plus u2 times v2 plus u3 times v3, and you get out a number, just a number, you know, let's say it's x, not a vector. So when you multiply these things together and add them together, obviously you're just going to come up with a number. So calculating the dot product is very easy. One thing I want to point out to you though is this, you know, when you think about the dot product, it's an important tool for manipulating vectors. Just as multiplying, adding, subtracting, dividing are important ways to manipulate numbers, in the same way the dot product and eventually, I guess next semester, the cross product and determinants are important ways to manipulate things like vectors and matrices. Okay? So what problem is the dot product going to help us solve? Where do we need to be able to perform this particular manipulation? And I've drawn a little wagon here, and imagine that it can only roll along the ground in this direction. We apply a force at some angle and say, well, how much of this force, F, maybe it's, you know, 10 newtons, is actually going to be applied here in the direction, because part of it will be dissipated kind of lifting the front end of the little cart. And we know that we could calculate that by simply taking the force times the cosine of the angle theta, and that gives us the amount of force that would be applied towards moving the cart forward. And this is a, you know, a non-vector approach to solving the problem. But we could reformulate this problem and say that F now is actually a vector showing us not only the direction of the pull but the magnitude of the pull. And we want to say, using this vector approach, how do we calculate the amount of force that's going to be applied? And it will turn out that we can kind of think of it as being close to this, but eventually, using the dot product, we're going to be able to figure a way that we don't actually have to look up the cosine of theta to find an answer. And I want to spend a little bit of time going through that right now.